We've learned that limits of polynomial functions can be evaluated using direct substitution. But we can extend that to rational functions too. Rational functions are just functions with a numerator and a denominator, where the numerator and denominator are both just some polynomial. So if we're talking about a function r of x, which is p divided by q, where p is a polynomial in x and q is also a polynomial in x, we can use our limit laws to apply the limit to the numerator and denominator separately. And as long as that denominator polynomial doesn't produce a zero, we can say that the limit of the rational function is just the numerator polynomial evaluated at a and the denominator polynomial evaluated at a. So again, we have to make sure that we don't create an undefined situation with the denominator being 0, and as long as that's not the case, we can evaluate these limits really quickly just by doing direct substitution. Let's try this function, 2x squared minus 3x plus 1, that's our numerator polynomial, 5x plus 4, that's our denominator polynomial. We're looking at the limit when x is approaching 3, and since 3 does not cause the denominator to be 0, we can go ahead with direct substitution. All we need to do is replace all of the x's in our function with 3. And simplify, we get 10 over 19. Let's try another one. X cubed minus 2x squared minus 1, all divided by 3x minus 2. We're looking at the limit when x is approaching 2. We double check that plugging 2 into our denominator does not cause a 0. It doesn't, so we can go ahead and evaluate using direct substitution. Replace all of the x's with 2's and simplify. We get negative 1/4. Let's try another one. We have x squared minus 1, all divided by x minus 1. Notice here that if I were to try direct substitution, I would have 1 minus 1 in my denominator, but I would also have 1 minus 1 in my numerator. And 0 divided by 0 is something that we cannot agree on as mathematicians. We know that you're never allowed to divide by 0, but we also know that 0 divided by another number comes out to be 0. So, can we solve this? No, we can't. There's not a consensus for what 0 divided by 0 is, other than we will call it indeterminate. I don't know what 0 divided by 0 means in this case. We'll have to investigate. So for this function, notice that it does not follow the rules. The denominator does turn into a 0 when we try to do direct substitution, so we cannot evaluate this limit using the technique that we used in the previous two. We need more techniques.